All right, now we're going to look at the algebra behind one-to-one functions. And here's the main idea. If to be a one-to-one function, it says that if your function evaluated at some point A is equal to the function evaluated at B, then A must be equal to B. Now this seems kind of trivial, but let's see two examples. In the first one, I'm going to show you an example of something that is one-to-one. In the second one, I'm going to show you something that is not. So let's take a look at our first example. Let's show that f of x equals 2x minus 5 is one-to-one. Okay, so here's what we have to do. We have to imagine that we're starting off with the definition. So let's start off by saying that f of a is equal to f of b. Okay? Now, if this is true, I need to now show that a must be equal to b. So what's f of a? We'll plug a in here for x, and you get 2a minus 5. Now plug b in here for x, and you get 2b minus 5. Okay, let's try and algebraically manipulate this thing. Let's add 5 to both sides. Add 5 here. They go away. I get 2a equals 2b. Now divide both sides by 2, and you get that a must be equal to b. And that checks. So we started out saying if these two were equal, we concluded that a must be equal to b. Therefore, it is a one-to-one function. Now let's take a look at something that is not a one-to-one function. Okay, so what I'm going to look at is the function x squared. And I'm going to show that this is not one-to-one. So I start out with my first assumption. I say, let's just say that f of a equals f of b. So what's f of a? Plug a in here for x, you get a squared. On the other side, plug b in for x, you get b squared. So we're saying, okay, a squared must equal b squared. But here's the problem. If we take the square root of both sides, you get the square root of a squared equals plus or minus the square root of b squared. Now, the square root of a squared is just a, and the right side is plus or minus b. That means that if these two are equal, we can conclude that a must be equal to positive b, or a could also be equal to negative b. And that's a problem, because in order to be one-to-one, we need this one to hold, and only this one. So the fact that this also can be true means that this is not a one-to-one function, and we can see how we can use the definition to check to see if it actually is one-to-one.